Today's webinar is entitled Digital Preservation Fundamentals, presented by Jacob Nadal. Jacob was appointed as the Preservation Officer for the UCLA Library in 2008. Prior to that, he served as the Field Service Librarian and Acting Head of Collections Care at the New York Public Library, and as Head of the Craig Preservation Laboratory at Indiana University. I'm now happy to introduce Jacob Nadal.
Hi, everyone. Good afternoon. This is the first in a series of 4 webinars that InfoPeople and California Preservation Program have put together to provide some sort of fundamentals in digital preservation. Today, we're really doing the real foundations. We're going to talk about sort of how computers work, how digital data is structured, and try to give you the tools and frameworks you need to think intelligently and think critically about digital preservation. In the future sessions, we'll look more specifically at particular topics, things like text and image formats, audio and video formats, and kind of repository software and how we store and deal with data. I like to start off by treating digital preservation as a specific part of preservation in general, and to start off by sort of asking if there's a general preservation framework we can use to think about all our records or anything in our collections, and then to talk about how that might differ in focus or intensity between digital and artifactual preservation. In digital preservation especially, like to come back to this notion that preservation consists in sustainable efforts that are optimized over time. And that is in some way just a jargon-filled way of saying we're going to start out doing what we're capable of and then try to improve as time goes on. I really encourage you not to feel that because of the potential technological mountains you can climb in doing digital library projects, don't be intimidated. It's worth starting out now, and if you do that in an intelligent fashion, you'll be able to build on that. Consequently, I try to be very careful of words like preservation and preserved, and really to, in digital preservation, talk about things being preservable, and to talk about the process of preserving them. So what we're going to talk about today is sort of how to make intelligent decisions as you get started, so that as time goes on, your collections will remain usable. This is a sort of general preservation framework that I find helpful. Like all things, it has its accuracies and its inaccuracies, but it's useful in trying to determine what the preservation issue at stake is, to divide the problem up into a couple layers. One of those layers are the materials that are involved, so a tangible substance that carries information, a sheet of paper, a clay tablet, a compact disc, a piece of magnetic tape. Connected to that is what I think of as a media, so the materials that actually record the information. Could be ink, it could be incised marks on a stone tablet, it could be a layer of magnetic particles on a spinning disc. All of those still depend on them having some means for perceiving the media. In our traditional libraries and archives, the transport mean was pretty simple. It was reflected light. If you're thinking about audio and video collections, right, you need an amplifier and speakers or headphones to get sound to you. If you're talking about motion pictures, you need light, you need a projection surface, right, and you need magnification. And then finally, there's some system for interpreting, right? So it's great to save a book written in French as long as you have someone who reads French around to benefit from it. And this becomes critical in digital preservation. That is, it's fairly easy to save the media, right, to keep a certain set of digital information around. The real question becomes whether we have someone who can read it back, or in this case, whether we have something, a computer and software that can interpret that data. So these things play out no matter what type of preservation we're doing. And one of the critical things to understand about digital preservation is that materials and media matter less than they do in our traditional library and archival work, right? If you can get something printed well on acid-free paper. In traditional preservation, you're fairly well done with your preservation work. In digital preservation, it's just the opposite. Putting something on a hard disk or a CD-ROM or a magnetic tape is really just a question of convenience. The real issue at stake is whether you can read it back and interpret it correctly. To sort of immerse you in this, I've chosen this example of talking about translating linear B. I think this is a pretty comfortable example for people who don't have a deep grounding in computer science. It's essentially the kind of artifactual preservation work we know how to think about already, but it demonstrates a lot of the issues that are at stake in digital preservation. Linear B was a Bronze Age Cretan script, about 1450 to 1375 BC. There were no cribs available for it. So the Rosetta Stone, we had these 3 copies of the text in different languages, which made decipherment fairly straightforward. With Linear B, we just had a lot of symbols, and this is the essential problem that digital preservation is trying to avoid or mitigate. We don't want to be left with a bunch of data that we don't know how to understand. So these tablets, clay tablets, were found at the turn of the 20th century by Arthur Evans, and this is what they look like. So it's a clay tablet that has characters inscribed into it, and you can see a sort of rendering of that made out of wire that shows the images more clearly. The first success was that the counting system was very easy to determine, and all records of this sort almost inevitably are inventory data. It turns out that people are much more concerned about who sold sheep to whom than they are about sort of preserving literary treasures. And this counting system is actually very comparable to something that happens in what we would call digital forensics, or this sort of branch of digital preservation that deals with recovering data. And many of the formats and encodings we'll talk about later in the webinar today are favored by the digital preservation community because they're easy to identify. So they have very characteristic features that mean that should you be left with a disk with unknown content on it, it's fairly easy to determine, for instance, if it's UTF-8 encoded Unicode text. Likewise, in Linear B, it was pretty easy to find something that looked like a counting system. That was a big step forward in recovering data from those tablets. There were 90 distinct characters identified that indicated a syllabic system rather than one that was an alphabet or one that was ideogrammatic that had pictograms. And then there was a debate over whether it was Greek or Cypriot, or many people felt it was a unique Cretan language. And this, again, is an issue that we're trying to avoid in digital preservation. So we'll talk a lot about encodings and file formats, and essentially what that's about is the vocabulary and alphabet that we're using to record data. So is a digital letter represented by 8 bits on the disk, or is it represented by 16, right? And if we know that, we're a lot closer to being able to preserve that data. We might want to know if that particular string of numbers represents text, whether it represents an image, whether it represents a sound wave, right? So knowing what we're trying to get back from the data is key to digital preservation. Alice Kober in the 40s recognized a sort of grammar, these word triplets. So it would be the same word stem with a different ending, and she assumed that was for the case of the word. And she separated, based on that, every word in Linear B into a modifier and word stem. Still, we had no idea what any of these words actually said, but we had a sense of how they were structured. Once again, this same pattern plays out in digital preservation. So as we talk about file formats, we'll often talk about them having different parts. A metadata piece, a header on the file that contains information about it, blocks of content, right? So the TIFF image file traditionally has a header, and the first 8 bits of it are very rigorously specified, and then it has further header information, right, to contain metadata, and that's followed by a content block, which is actually pixel by pixel the colors that are going to be displayed on the screen. A database is another example. So if you've worked with Access, you may have had the experience of changing the type of fields, changing something from text to a number, and getting a cryptic warning from Access about the number of characters or bit length assigned to this field has been altered and data may be lost. And it's because the computer has gone and parsed out your disk into a certain structured series of cells in which it's going to store data. And when you change from text to number in this case, it has to reassign space on the disk. So there's a structure to the data. It doesn't matter at this point what you're going to put into that structure, but it matters that we know what that structure is. The next step in deciphering linear B was establishing a pattern of consonants and vowels. And this is why I think linear B is such a great example for talking about digital preservation, because this is essentially the problem of compression, right? So in linear B, as in, if you know Semitic languages, Hebrew or Arabic, it's very common for vowels to be omitted or pointed in some way. So what you really have is a string of consonants that you interpret. And there can be great debate about what the proper vowel is to insert into a word. Likewise, in digital resources, when something is compressed, some amount of data has been removed, and there's a rule for decompressing it, for adding that data back in. And this is why in digital preservation you will hear over and over and over again that we try to avoid compressed file formats, right? Because if we ever have uncertainty about how something was compressed, or if we have a type of compression that allows for loss of data, as we move generation by generation further into the future, it's more and more likely that we'll have damaged data in our archives. This, just for those of you who are, like me, as interested in sort of ancient languages as modern ones, this is a chart of all of these linear B characters. And you can see how it works. You have a string of consonants along the left-hand side and a top row indicating vowel sounds that let you decipher the text. And so then, in fact, all of that work having been done, a few guesses were made, right? This appeared to be inventory data. If you're kind of doing commerce in the Mediterranean in this period of time, there are some Greek shipping towns that are likely to show up. And in fact, doing this allowed some town names to be recognized, and from there it sort of fell out that this was not a unique language. It was Greek written in a different script. And this, again, is similar to what happens in digital preservation, where we don't know what a file is. We make some educated guesses. We try to determine what the structure is. And then occasionally we'll find out that, in fact, the data that's contained there has been put into, say, a proprietary format. An example would be some of the early ebook formats were really just PDF files with a few bits at the beginning swapped around. If you knew that, reverse engineering them and getting the PDF data out was trivial. If you didn't, it was a completely obscure file format. And this is then sort of the final theme that you'll hear coming up as we talk about digital preservation, is avoiding proprietary file formats. Not because they are necessarily more complex or impossible to solve technologically, but because they introduce another element of the unknown. I was involved at the turn of the 21st century with an early book digitization project, and that used a proprietary system so that every book was structured with XML metadata, but the XML file was not named or identified as XML. And then the pages were captured as TIFF images, but the TIFF images were not named or identified as TIFF images, and they were not sequentially numbered in base 10, they were sequentially numbered in base 37. So what you had was essentially an XML file and a lot of TIFF files, which is ideal in digital preservation terms, but it had a layer of complexity added to it that was proprietary to this system, which made it very hard to use that data without doing a lot of reconstruction. So just to recap, digital preservation is trying to deal with a couple core problems. And one of those, and the part that you will hopefully never have to get your hands very dirty with, is this really low-level identification of parts and types of files. And in the literature and in digital preservation conversations, you'll hear that referred to as digital forensics. Those of you who work in archives are probably hearing some discussion in your professional circles now about digital forensics, so tools that are used by oftentimes military and law enforcement to decode data from unknown or questionable sources. Those tools are now being reused to deal with obsolete-born digital files. Those parts, that sort of raw digital data, is then associated with possible informational content. And this is why we care so much about metadata and contextual information, right? Because it tells us something like, this is a collection of images, which immediately narrows the scope of what type of data we're looking for. And then there's a third layer of this whole digital library ecosystem that's really about data curation, right? And that's understanding what the data is and how it's meaningful. And so there's an emerging conversation around, so for instance, if you have the results of a survey collected in the field, and the way that data manifests itself is a table of numbers. Well, keeping the table of numbers is fairly trivial, but if you don't also know what each column in that table stands for, it's very difficult to work with that data in the future. And that's a curatorial question that has to be addressed. So I'd like to move now into some more contemporary definitions of digital preservation. And we're going to look at work that was done by the American Library Association to try to have for its membership a more concrete definition of what digital preservation is. And this process of crafting a definition of digital preservation actually led to quite a long definition that we'll look at in a moment, because there were so many possible routes to interpret it. And so the committee boiled that down into a short, medium, and long version. And the short version was simply that digital preservation combines policies, strategies, and actions that ensure access to digital content over time. Now, astute readers will notice that if you remove digital from that sentence, it's a fairly good generic definition of preservation. So the medium definition that we'll look at adds some more strongly digital concepts in. But I want to take a moment to look at these sort of key words of policy, strategies, and actions. The assumption, and I think it's a good one, is that your institution has to know what it's trying to accomplish. It has to have a sort of policy, just the way you would have any other collection development policy. And this has nothing to do with specific technologies. It has to do with making sure that you're focusing on institutional priorities. Having that, you need some strategies, and this is really where this webinar and the others in this series ought to be helpful to you. You ought to be able to make some decisions about the type of file formats you're going to use, the type of systems you'll use to store them, and knowing how that's going to play out in a sort of risk-managed fashion, right? So choosing a TIFF format for our images, we know that TIFF files have been stable for about 20 years now. It's a well-established technology, so we might feel very comfortable with that. On the other hand, it's within your institutional policies that you'll collect video or video games, right? You might know that those formats are not as mature, they're not as stable, and so your strategy will simply be to choose a file format now and then plan to make a migration or change sometime in the fairly near future. So knowing your strategy is really about kind of managing your risks and having reasonable expectations of how long your data will be useful. And then finally, our actions, right? So having decided all of that, well, maybe it's time to start digitizing video, even knowing that you may have to touch those materials in a few years. Likewise, maybe you feel very comfortable starting an imaging project, but you want to put video on the back burner for a few years to see if things will stabilize a little bit. And then, of course, the final piece of this is just recognizing that in preservation, time is always an issue, right? You can do the right things right now and forecast that those will put you in a good position for several years to come, but almost inevitably in digital preservation, there's some sort of migration or alteration of your system that has to happen just because technology changes. As we expand into this medium definition, the definition's scoped a little bit more to mention both reformatted and born digital content and to raise these questions of media failure and technological change. Reformatted and born digital are probably familiar to many of you, and what that speaks to is just the recognition that some content we're converting from our artifactual holdings. We're scanning a photograph, we're transferring an audio recording, we're transcribing text, right? And when we're doing reformatting work, we really have the option, and it's really incumbent upon us to choose the best, most sustainable format, right? So if you're engaging in a reformatting project and you are not choosing sustainable file formats, you're really not only causing a problem for yourself, you're causing a problem for whomever it is who inherits that material from you. On the other hand, we often get material now that was created digitally far outside of our control. Libraries license a great amount of material. Archives are now bringing in materials created digitally by authors. And in those cases, the question is whether that format is sustainable in its native form or whether it has to be migrated in the future and how soon that future is. Media failure I touched on just at the beginning, and I just want to reiterate here that media failure can be a question, right? So a hard disk, a CD-ROM, a magnetic tape, they certainly have a lifespan, but increasingly the way we store digital data is what we would call media independent. And we'll talk about this in one of the future webinars, how repositories are built so that they don't rely on any single piece of media in them. All the media that are used for storing digital materials are fairly fragile in library and archival terms. And then the other piece of this is technological change, right? We've seen this play out recently. A great example is whether Flash is a viable format anymore, right? So as more and more people have begun accessing web content on mobile phones, on the Android and iOS platforms, Flash support is very poor, and that's such a large audience that many developers have moved away from using Flash. And so here's a format that was well established a couple of years ago and now is really heavily under threat. This happens fairly routinely in the digital landscape. The final piece that's mentioned here in the medium definition is accurate rendering of authenticated content. Authenticated content really is a nod to provenance, right? That we want to know where the content came from and that we have certain rights over it. One of the things we will not spend a lot of time on in this webinar series are the myriad legal issues that come into play in digital libraries. I don't see that there's a groan button on the interface, but I'm sure if it was there, you'd all make use of it. Intellectual property law is more and more day-to-day involved in what we do in libraries and archives. And of course, digital materials themselves have been subject to some very specific law in the Digital Millennium Copyright Act. And so the authentication, right, knowing that it's our data and that we have rights to it is a critical piece of success here. And then the other piece is accurate rendering, right, so that I know that I'm seeing today what you saw yesterday. And accurate rendering becomes important in digital preservation in a way that's distinctive from other library and archival environments, because often you're rendering content to be interpreted by a computer before it ever reaches a person. So we need to pass accurate data to a piece of software that will then manipulate that data to display it for a person. So oftentimes, especially in the sciences, accurate rendering means that the data set that I worked with in my experiment, you can work with again to verify my experiment. It doesn't really ever matter if a human sees it or not. So the computational side of data use makes a difference here. Thanks. I see I got a groan. So there's a long form of this definition as well. You can imagine how trying to make a definition of digital preservation that's all things to all people, whether they're a one-person historical society or a 20-person particle physics lab, can be a challenge. And so the long form definition sort of pulls together many of these concepts into one place, right? Policy, strategies, and actions to ensure accurate rendering of authenticated content over time, regardless of the challenges of media failure and technological change, and applying that to both born digital and reformatted content. And then more specifically saying that policies document an organization's commitment to preserve, right? So that's sort of your collection development piece. They specify file formats to be preserved and the level of preservation to be provided. So you'll see commonly in archival terms of use and understanding that, you know, we will keep your Word documents, but we won't guarantee that they will be meaningful to you. We'll return the bits, or we'll do bit level preservation. For other formats, archives may promise a much higher level of preservation. They may promise to sort of translate and migrate data over time. And then to sort of deal with both the creation, integrity, and maintenance. The long form definition actually goes on yet further to talk about some specific points of content creation, integrity, and maintenance. And I think those are worth spending a little time on. But content creation is really talking about how you are going to produce data, and there's a notion embedded in digital preservation that when we reformat, we create a master file that is uncompressed, minimally altered from the source capture, right? So no sort of sound and photo editing involved. This is a pretty raw capture from the device. And that it's going to be accompanied by sufficient metadata to ensure future access. And that from that master file, we'll create the derivatives that we actually deliver to someone over the web, or create a version that's usable in a print book. Integrity assumes a couple of things. One is documentation, which of course which applies to integrity of almost any archive or library of any sort. But specifically to digital preservation, persistent identifiers are important. So unique file names that are relatively content-free. So a classic example of this is that you scan a collection of photos for an exhibit on, say, Old Town Sacramento, and you name all of them Old Town Sacramento 001, Old Town Sacramento 002. 10 years from now, you may want to do an exhibit on California architecture, right? And it's difficult at this point to have your files so closely associated with a particular project. Better to have a generic file name that lets your content move more easily between future applications. Another important piece here for thinking about sort of core issues in digital preservation is this piece about verification. So it's very common to create something called a checksum or message digest. And this is simply a number that's computed based on the file. So a file is a string of yes and no bits, zeros and ones on a disk. And you essentially factor those to create a checksum. And one of the common checks in digital preservation is to compare, after copying a file from one place to another, whether you get that same checksum back, because that will indicate to you that data has or has not been changed. It won't let you then go back and correct any errors that were introduced, but you will at least know that there was a problem and that you need to go back to a source file. And then content maintenance really speaks to the question of how you're going to keep these data intact. And we'll spend a whole hour on this in one of the future webinars, but this is really thinking about how do you store your data, how do you migrate and refresh it, how do you keep those systems up to date. All of that said, I don't want you to get lost in the fine print on this stuff right now. And remember that what all of this definition is saying is simply to create good files, right, to make good choices about the type of data that will be in your archive, to keep an eye on them, right, to have a plan for going back and verifying that they're still doing what you thought they were going to do, and then to store them safely, right, so to have reliable storage that's not dependent on, for instance, the single hard drive that sits under the desk of the person who drinks a lot of coffee. It's a bad way to store your files. Having multiple copies in multiple places, a much better way to store your files. There's a question about persistent identifiers that I think is a good one for us to come back to, but let's catch it at the end. So I want to take just a moment now and talk about sort of a couple of basic file types that exist in digital libraries, just to sort of frame some basic issues about these. One of those is good old text. The really common standard now is UTF-8. That's a way of representing Unicode, and Unicode is a vocabulary for representing essentially any type of character or glyph. And UTF-8 is really the standard for digital preservation. Some of you may have ASCII text in projects, and there's nothing unreadable about ASCII text. In fact, the first 256 characters of Unicode are the ASCII character set, but increasingly UTF-8 is the expectation. And if you're doing text projects, that's really sort of the bar you want to be meeting. Remember that digital text is purely character data, so a digital text file says nothing about font or layout information. So whether it's in Times, Frutiger, Arial, Helvetica, those font files are actually separate pieces of digital information. Text is just the text. And it's critical for searching and manipulation, right? So when you do a text search, this is what the computer is looking at and indexing. Without that, you know, an image of a page is just an image of a page. It's only once you have text that you can actually begin to search and manipulate. And then finally, it's worth noting that XML, which I'm sure you hear about every day of your lives now, is a UTF-8 text format. So actually the glyphs that form an XML file are UTF-8 encoded text. So it's really a fundamental piece of our digital library infrastructure. The other, probably next most common type of data for us to work with in libraries and archives are images. The TIFF tagged image file format is really the standard preservation format. JPEG 2000 is emerging as an alternative, but is not well established yet. A couple notes about these that go a level deeper than just the .tiff at the end of the file name. Both TIFF and JPEG 2000 are fairly broad specifications. So it's possible for a TIFF file to contain uncompressed image data. So it's important as you create digital images to go carefully through the software that you're using and make sure that it's not applying compression at any point. Likewise, when you work with vendors, it's important to be clear to them that you're looking for uncompressed, what's called raster image data, R-A-S-T-E-R. That just means a grid of pixels, right, is an uncompressed raster of image data. The files you're creating, generally we look for files to be at least 300 pixels per inch. That's roughly the point at which the eye can't distinguish the individual pixels. Your vision may be better or worse than your neighbor's. Your mileage may vary here, but 300 is a pretty reliable guideline that will allow you to be flexible with what you do with those images. It's increasingly common to see 600 or even 1200 DPI used in imaging projects just because sensors have improved. And essentially what that buys you down the line is that you can do more sort of virtual magnification before you start seeing the graininess of individual pixels. It's also fairly standard now to do 24-bit color. So this means 8 bits in each of a red, green, and blue channel. And in the text and image webinar, we'll actually look at some examples of how color is created and captured. 24-bit color, like 300 dpi, gets you to the limits of what most people's eyes can readily discern. And then the final piece, and I think the one where libraries and archives drop the ball most often, is in calibration and profiling. So there's something called an ICC color profile that can be created for each device that's used to capture color, and that attaches to the image file, and it is essentially a piece of metadata that says this color red, right, that we've recorded with these 24 bits corresponds to this color in a sort of universal color space. Very important if you want to have images that are going to be used later for republication or reprinting in different media. Increasingly, we're seeing libraries and archives work with audio data. The standard format for storing audio data is the broadcast WAV file. And this is really just a WAV file with a metadata header attached to it. Header here is a technical term. It actually quite often is written at the very end of the file for reasons that we'll talk about in the audio webinar having to do with how audio data is stored. WAV audio should contain uncompressed pulse code modulation. PCM dates back, the math of it was described at the turn of the 20th century. So we've been broadcasting PCM audio for nearly a century now. It's a pretty reliable, time-tested format. And essentially it's a method for sampling over time the way a waveform looks. That's done on a CD 44,100 times per second. And in most digitization of audio, actually we sample at an even higher rate of 96,000 samples per second, 96 kilohertz. That determines how often the computer essentially listens to the audio to capture information about it. The other piece, just like having DPI and bit depth for a color image, is the bit depth of the audio signal. So a CD chunks each sample into 16 bits. When we're digitizing for preservation purposes, we prefer to go even deeper to 24 bits, and that measures essentially the amplitude of that waveform. So you'll hear people refer offhandedly to 4416 as CD quality audio and 9624 as sort of preservation quality audio. And then finally, a lot of places are working with video and moving image now. This is an area where standards and practices are still very much in development. Some general rules of thumb are that uncompressed is desirable. Unfortunately, there are very high storage costs associated with that. You quickly are talking about several terabytes of data just to transfer a couple hours of video. Consequently, compression is fairly normal in video, but will inevitably cause preservation problems down the road. The current safe bet is something like an uncompressed AVI file. That will be an enormous file. Motion JPEG 2000 and MPEG 21 are options, but no one has very good hardware or software to work with those file formats. And there's something called H.264, which is a compressed video format, which is really becoming a standard for service copies. If you have to be doing video, about the only realistic guidance I can give you is pick one and plan on doing a migration probably in the next 5 or 10 years. And I say that as a guy who is in the midst of picking one and planning on a migration in the next 5 or 10 years. There's no magic trick here. This is just this part of our technological life is still sort of in its adolescence. A couple quick notes. Data and sort of interactive resources are emerging on the scene, right? So how do you preserve a video game? How do you preserve computer art? this brings in a lot of curatorial questions. Are you trying to store the whole interactive work? Is sort of a representation of it appropriate? Likewise, what's in the artist's intention, and how are you going to translate that over time? I've given you a couple links here. If you're finding yourself going into this woods, we should exchange some emails. I would love to hear what you're doing. This is, boy, if you think video is complicated and problematic, preserving a video game is an order of magnitude deeper into the soup. And then finally, no presentation is complete without a nod to metadata. The sort of big defining document for digital preservation is called PREMIS, Preservation Metadata Implementation Strategies. And I think this is really probably the most important part of the entire enormous PREMIS document is this reminder that preservation metadata is a subset of the metadata you will need for most other applications. So some pieces of descriptive metadata are important. Knowing some things about the specific format used are important. Information about kind of rights and media are important. So preservation metadata is not something that you should think of as a standalone piece of metadata. It's a certain sort of frame that you put on the contextual information that you need in your digital library. And then finally, I just want to give a quick nod to storage and maintenance. There are lots of options out there. LOX networks, digital archive services like OCLC or DuraSpace, do-it-yourself systems, right? I know archives who are doing a fine job right now just by having a couple removable hard drives that they swap out. People contract with Amazon now for cloud storage. Ambitious people can build their own data center. All of these are viable, and the issue really is kind of, apologies, where you're trying to go with your archive. And there's some good documents. The RLG Trusted Digital Repositories framework sort of is a good way of thinking about whether you have touched on every important issue, and more importantly, if you're thinking of outsourcing your digital storage, whether your vendor has thought through how they're really going to keep your data intact. And then this is the piece that you will hear referred to over and over again, the OAIS reference model, which essentially just describes these three phases in an archiving process where there's a submission information package, an SIP, that is given to the archive. The archive manages that data and adds metadata of its own to the submission information package, and then it disseminates it in some fashion. Sometimes that's very simple. I give you a TIFF file, you store the TIFF file on a storage network, you give me the TIFF file back. Sometimes it's very complex. You know, I give you a PDF document, you disaggregate that into text and images and metadata, and you return it to me through the web browser. Both of those things could be OAIS like or OAIS compliant. They just speak to different needs. So OAIS is a reference model, a way of sort of thinking through your process to make sure that it's viable. So finally, just to end with some reasonable expectations, recognize that digital preservation has strong and weak points, just like artifactual preservation does. I think when you're dealing with computer systems and digital systems, you should expect high day-to-day reliability. The fact that we're doing this con call right now with 158 participants all over the state of California, me talking in my office in LA, showing you slides that I emailed to Stanley a couple of weeks ago, should speak to some extent to the reliability of these systems. It's incredible that all of this works as well as it does. Likewise, with digital preservation, you skip over acid decay, mold, biohazards. Those are great things to avoid in preservation. But you will have some preservation problems in the future, and it's just sort of part of the digital landscape that a migration is eventually required. Good planning means that it's required further into the future and that it's less painful when you do it. But this is not, there's no digital preservation solution that relieves us of that burden, and if someone is offering you one, also ask about, bridges in Arizona that they might sell you. And then finally, just a couple of frames for this. One is digital archaeology, right? And this is really what we're trying to avoid by doing digital preservation. We don't want to be doing this kind of complicated recovery and forensic analysis. Likewise, we don't get much into conservation, right? So if your digital preservation plan is to keep all of the original equipment running forever, you have a big, big mission ahead of you. Computers are not built to last. Most of what we do right now in digital preservation is bit preservation. So it is storing and refreshing the data in the contemporary format so that it's not lost because a hard drive burns out. Upcoming in the future for most of us is migration or emulation of that data to make it useful in the future. So to put a timeline on that, in some sense, you should almost never be dealing with digital archaeology or conservation unless that's the specific mission of your institution. You will right now and will be forever dealing with bit preservation, right, keeping that data intact. And then I think for all of us, it's reasonable to expect in the future, and hopefully in the more distant and simpler future, that we'll be doing migrations and emulations. So with that, thank you. And I've tried to leave 10 or 15 minutes here for us to do questions. You'll also see a link to my website with jacobnadal.com/247. That page will be persistent. As an alleged digital preservation expert, I'm at least willing to say it will be there as long as I am. And if you have follow-up questions or comments, there's a place on that page where you can submit them to me, and I'll get back to you. So thank you. And I'll turn it over to you. You can type questions into the Q&A box, and I'll keep an eye on the chat as well. And let me start off. There's a question from Melissa about an example of a good persistent identifier. In some ways, this is probably easier to answer in the negative. If your file naming convention includes descriptive metadata, you're probably going down the wrong road. And the higher level that descriptive metadata might be, the better, right? So, and for instance, you're digitizing something, images from the LA Times. Well, if you name them LA Times and give them a serial number, not too big of an issue. If you're naming them because they are part of an exhibit or a virtual gallery you're creating, down the road, those file names may make less and less sense to people. Likewise, if the meaning of a file is dependent on the folder or the directory it's stored in, so to use this example again, say we have a directory of LA Times photos, and internally they're just numbered 1, 2, 3, 4, 5, 6, 7. If they're ever disaggregated or pulled out of that directory, their uniqueness falls apart. So one way to think of this is sort of that every file should have a globally unique name, or at least some sort of registry, much like we do with books and barcodes, right? So that every book in the library has a barcode on it that attaches to a unique record. So a good persistent identifier is one that is generic, right? So it doesn't convey a lot of descriptive content, and that it's unique. This gets more important the larger and more complex your archive becomes. So for instance, in the University of California, we use something called an ARC, an archival resource key. We have a shared piece of software that creates these globally unique identifiers. If you're starting out with a small digitization project locally, just making sure that everything has a unique file name and that the file names are not also the description of the item is probably a pretty good start. Year and date in file name, there's nothing particularly wrong with it. Again, this is the question of whether your year and date are lead you to something else, right? So if you wanted to stamp every file as sort of year and month that it was created, followed by a serial number, that would give you a pretty decent file name. And what's important then is that you have some sort of registry where, as you create the metadata for those items, you reference back to that unique name. Great. Other questions? I'm looking in chat here. So there's a question here about 48-bit color images for preservation purposes. Something to be aware of, it's pretty easy. I think you can go to Costco now and get a scanner that will advertise that it's scanning 1200 DPI 48-bit color, and it may not be. So oftentimes at those bit levels, what you're getting is interpolated or interpreted data. So 24 bits are being scanned, and then the computer is using some algorithm, some formula to fill in extra color around it, right? Or it may scan 300 bits and then mathematically create another 900. That is A-OK for the first generation file. The quality of image becomes progressively less over time. It's also distinctly different from capturing with a sensor that actually reads 48 bits of color, right? Most of those algorithms are built because they know how the human eye is going to interpret color. They're not built to actually capture the color as it was reflected. This may seem like a sort of academic distinction, but if, say, you're going to do a search for every image in your collection that is a particular shade of red, it in fact matters quite a lot whether you get accurate color data so that you can perform that search. So it's worth pressing when you see sort of extraordinary levels of image fidelity advertised to find out exactly where it's coming from. Oftentimes what happens is that the scanner captures data at a lower resolution, hands that off to software on the computer, and then that software essentially expands that file. And it brings with it all the sort of same problems that we have with compression and other file formats. So there's a question here about multiple copies of the same content. So as an example, the library accessions an original VHS video of an oral history interview and then has a migrated digital copy. A lot of this depends on sort of origin, right? So there's a legal question implicit here, which is that do you have the rights to sort of copy and preserve your files? Broadly speaking, you probably do if it's something like an oral history interview that you conducted. In this case, I would think of the digital copy as essentially the master version, right? The VHS format itself is probably not long for this world and is degrading all of the time. And so, although I would not consider the digital thing an artifact per se, that is, it's not a tangible object, I would start to think of that as my preservation master and would plan for maintaining it over time. Also a question about kind of what to do with outdated formats. It's worth looking, one of the sort of routine checks one should do is as you start having a digital library, and sort of knowing the file formats that are present in it and looking for equivalent file formats. So if you had an archive of WordPerfect documents, now would be a good time to think about what word processing format you might move them to. So at the point that file formats change, people tend to have to do migration. Software is written to facilitate that conversion. As time goes by, the bulk of people have made the transition, and if you're sort of left holding the hot potato, there may not be an easy way to migrate that content from format A to format B. A question about sort of how to tell if your scanner's being honest with you. This is maybe more art than science. Every scanner should have some sort of piece of technical specifications that will tell you what its capture device is. So you're looking for something about the image sensor itself, which is usually a CCD or a CMOS, CMOS sensor, and it should tell you the native resolution. And that question of native resolution is really the key phrase that you're looking for. Question about email. There are not well-developed standards of archiving email. There are several projects that are exploring this. One common piece of infrastructure is the mbox format, .mbox, which is a common way of structuring email data. But email is often very closely tied to the system that's used to create and send it. So there are formats like mbox and systems that read the sort of lingua franca of email, but each system has its own idiosyncrasies. For a project we're doing here at UCLA, actually, we simply exported all of the email from its source format and loaded it into a new instance of, I think we use Microsoft Outlook, so that we now have a PST file. That's not permanent or even recommended, but it's what we're using for the library anyway, so at least it's part of our technological herd. And that, points to another kind of example of sort of the perfect and the good. That if you can keep yourself to a few technologies, it's oftentimes better than having many, right? That is, if you can kind of find a herd to run with, it at least means that when a problem occurs, you're not the only person having it, which can be very advantageous in digital preservation. Question about digital archaeology. Digital archaeology is really a sort of term of art that's used for recovering data from media, right? So when you don't know what the content of a particular hard disk or compact disk, or choose whatever it is, when you don't know what the content of that is, you have to do digital archaeology or digital forensics to figure out what's stored there. So you'll do some tests to say, for instance, well, gee, I think it's text data. Does anything on this disk look like a text string? Or I suspect there are images on here. Do I see anything that looks like the TIFF header? And that's really this process of decipherment. And the point of choosing standard file formats, avoiding compression, and sort of staying within the world of digital preservation standards is that, one, that you avoid having to do that in the first place, and that, two, should it come to that, right, should there be some catastrophe, fire in the machine room or whatever it is, it will be very easy to determine what types of data are stored in your archive.
Well, Jacob, it looks like we're at the top of the hour, so thank you very much for a very informative webinar.
Thank you. I hope this was enjoyable for everyone, and I hope I'll see some of you in the future installments in this series.
Yes, and as a reminder, there will be other ones, and I posted a link in the chat to the list of archives where we will be posting the links to the ones that are coming up, and the next one will be in January. So thank you all again for attending, and as you leave, there will be a survey, and we hope to see you at the next webinar. Thanks very much.
Great. Thanks, everyone.